Hello, in this video we'll talk about Newton's second law, also called N2L, yeah? So if we mention Newton's second law, what comes to your mind? I think most students will say F equals ma. But that's the O-level version of Newton's second law. So you're now an A-level student, you've got to be more sophisticated. So Newton's second law is now not F equals to ma, but F equals to dp dt. So who is P, right? Who is P? P is actually the momentum, which is defined as a body's mass times its velocity. So remember, Newton's first law says that to change motion, we need a force. So Newton had to have a way to quantify the amount of motion. So according to Newton, the magnitude of the amount of motion is the product of mass times velocity. Which kind of makes sense, right? For example, the elephant has quite a respectable amount of momentum simply because of its large mass. Yeah? A bullet also has quite a bit of momentum because of its high speed. Next thing to notice is momentum is a vector quantity. It simply follows the direction of the velocity. So let's suppose a body has a momentum of 4 kg meter per second. It may be because it's a 1 kg traveling at 4 meter per second. It could be a 4 kg traveling at 1 meter per second. It could be 2 kg traveling at 2 meters per second. It's not important. It has a momentum of 4 kg meter per second. And let's say 2 seconds later, it has a momentum of 8 kg meter per second. So based on Newton's second law, you say, I smell a force. Because there's a change in momentum of 4 kg meter per second rightward. So what is the magnitude of the force? So it's the rate of change of momentum, a change of 4 kg meter per second that occurred over 2 seconds, that gives us a force of 2 newtons. Yeah, get it? The direction of the force is rightward because the change in momentum is rightward. So a 2 Newton rightward force is required to result in this change in momentum. Yeah? Okay, let's say we start with 8 and then 2 seconds later it slowed down to 4 kg meter per second. So again you say, I smell a force because there's a change in momentum of 4 kg meter per second leftward. So the magnitude of the force, you can calculate again, is 2 Newton, but this time the force is leftward because the change in momentum is leftward. So you need a leftward 2 Newton force in order to slow down this thing so that its momentum change from 8 to 4 kg meter per second. One more example. Again, we start with 4. 2 seconds later, it becomes, an upward momentum of 4 kg meter per second. So is there a force? Yes, there is, because there's a change in momentum in this direction. So this is a reminder that momentum is a vector. So you cannot just look at the magnitude that's 4 and 4 and say there's no change, right? Because the direction did change. So you have to do a vector subtraction, which will give you root 2 times 4. So the amount of force is the change in momentum divided by the time again, and it's going to give you 2.8 Newton. So what is the direction of the force? Along this direction, all right? Remember, the direction of the force follows the direction of the change in momentum. So you need a force of 2.8 newtons in order to cause the momentum to change from a rightward one to an upward one of 4 kg meter per second. So coming back to force equals to dp dt. Now if we write P as m times v, yeah? And if m is constant, then you can pull out the m and then end up with this thing. What is dv dt? dv dt is just the rate of change of velocity, which is acceleration. So net force equals to ma is a special case of the more general F equals to dp dt. Then you ask, is there a situation when, P is m times v, but v is constant, but m is changing? So in that case, you can pull out v, and then you are left with F equals to v dm dt. Yeah, actually there is. If we use our imagination a bit, we can actually have scenarios when it looks like the velocity is constant and the mass is changing. And we'll talk about that in later videos. So this is what you have already learned in O-level. So in A level, we give you more complicated problems. And this is new in A level. And then besides this, we are also going to make you calculate impact forces using delta P divided by delta T. And you also be introduced to this concept called impulse. Yeah. So F goes to MA, you have learned it. It's just going to be more complicated. And then you got 3 more new things to learn here. I hope you're feeling excited about it. See you. Ta-ta!